The next term we're going to learn about is called mutually exclusive. Another word for that would be, maybe I'll write it up here, disjoint. It means the same thing. If you have two sets that are disjoint or mutually exclusive, the counting formula is a little bit different. We already learned, maybe I'll put down here, recall, this is always true. The probability of E union F is equal to the probability of E plus the probability of F minus the probability of their intersection, because we don't want it to get counted twice. Remember, E intersection F is completely contained inside this, and it's also completely contained inside this. So if we add this to this, the probability of E intersection F gets counted twice, so we have to subtract it once. Okay, so that's what we knew. That's always true, and it still is true. But if the two events are mutually exclusive, that means that their intersection, by definition, is the empty set. This is the definition of mutually exclusive. And remember that the probability of the empty set is 0. It can't happen. All right, so in this case, this number, the probability of their intersection, is equal to 0. So when the sets are mutually exclusive, the probability of E union F is equal to the probability of E plus the probability of F when they are mutually exclusive. Okay, so a Venn diagram of that would be this. When they're mutually exclusive, they don't overlap at all. Just like that. So let's say, I'll just make up some numbers here. Let's say the probability of E is 25%. Probability of F is 45%. What goes in? Now we don't have 4 regions. We only have 3 regions because there's no overlapping region. We've got this one, and then 45 and 25 adds up to 70. So this would be 0.30. So if they are mutually exclusive like this, you can think of it as if I randomly threw a dart and it hits somewhere in this Venn diagram, 25% of the time it'll end up in E. 45% of the time it'll end up in F. How many times, what's a percentage where it'll end up in one of them? Well, either this or this, just add them up. 0.25 and 0.45 would be 0.70. And this is not a trick question, but what's the probability, given this diagram, that the dart ends up in both of them? One dart ending up in 2 different places. Impossible. So in that case, the probability would be 0. That's why this goes away. Why we don't have it. Again, this is the formula only for when E and F are, their intersection is the empty set. That means that E and F are mutually exclusive. That's an equal sign there. All right, so when tossing a coin, let's make sure we understand mutually exclusive. When tossing a coin, are the events heads and tails mutually exclusive? Well, the event heads would be simply this. The event tails would be that. Do they have any intersection? Of course not. You can't flip a coin one time and have it end up with heads and tails, both. So of course they are mutually exclusive. They can't both happen with the same toss. When rolling a pair of dice, remember what you do when you roll a pair of dice, we add up the 2 numbers that are showing. Is rolling a 7 mutually exclusive with rolling a 10? Well, that should be easy to say, of course. Is it possible that you could roll 2 dice and they both add up to 7 and 10 the same time? No. Of course, that's a yes. What about rolling even versus rolling odd? So the even numbers when you roll 2 dice would be 2, 4, 6, 8, 10, 12. The odds, that'd be evens. The odds would be 3, 5, 7, 9, 11. Are they mutually exclusive? Of course. You cannot ever roll two dice and add up the sum, add up the two numbers, and get both even and odd. So yeah, of course. What about rolling at most 4 and rolling an odd number? Well, could you roll a number that's at most 4, which means it's a 4 or less? It could be a 2, 3, or 4. And roll an odd number? You certainly could. This number is in both sets. It is odd, and it's also at most 4, so this is the only one where they are not mutually exclusive. This set would contain 2, 3, 4. That's the at most 4. And odd would be 3, 5, 7, 9, 11. Are these disjoint or mutually exclusive? In other words, is their intersection the empty set? No. The number 3 shows up in both. So they are not mutually exclusive. All right, so here's our last problem of this video. Two people are selected at random from a group of 7 men and 5 women. So I always like to draw a picture. 7 men, 5 women. So how many people do I have in the group? 12. 2 people are selected at random. Don't be tempted to say that the number of possibilities is 12, because it's not. If we were only choosing one person from this group, the number of possibilities would be 1. Would be 12. Sorry, you would just add them up because you're choosing 1 out of the 12. We are selecting 2. So what is the denominator going to be in all cases when we're looking at probabilities of this? The denominator is the total possible number of outcomes of choosing 2 people from a group of 12. So the denominator is always going to be that. All right, and then the numerator is going to be the number of ways that we're able to do the favorable event, what we're looking for. All right, so let's find the probability that both are men or both are women. This is the tougher one because of the word or. Or means we're going to have to get 2 probabilities, or maybe number of ways that 2 different things can happen, and add them together. We have to add up the number of ways we could choose 2 men and the number of ways we could choose 2 women. So I can tell you very quickly what the unsimplified answer is. The unsimplified answer is going to be, I'll go way over here to the left just in case I want to work it out. How many ways could we choose 2 men? Well, how many men are there? 7. How many ways can you choose 2? 7 choose 2. In other words, combination of 7, taking 2 at a time. How many ways? And then we add it to, because only one of these is going to happen. 5 choose 2. Over the combination of 12 choose 2. That is the answer. I will never have you leave the answer like this on an exam. But if I saw this on an exam, you'd get half credit at least. Okay? Half credit for just doing that. I want you to do the arithmetic. So let's see if we can figure it out in my scratch paper over here. What is I remember I've done 5 choose 2 so many times, I know the answer is 10, and not because it's 5 times 2. Turns out to be 5 factorial over 3 factorial 2 factorial, which is 5 times 4 over 2, which is 10. 7 choose 2 would be, that would be 7 factorial over 5 factorial 2 factorial, which is 7 times 6 over 2. The 2 factorial is just that 2. 2 times 1 is 2. 7 factorial over 5 factorial. The 5 factorial completely cancels out on the bottom, leaving you with the 7 times 6. The 5, 4, 3, 2, 1 canceled with this 5, 4, 3, 2, 1. That's 42 over 2, which is 21. So this is 21 plus 10 over, well, 12 choose 2 we're going to need every time. So let me go ahead and work it out over here. That's equal to 12 factorial over 10 factorial, 2 factorial. 12 minus 2 is 10. 2 factorial is just 2, so I'm going to get a 2 in the denominator and a 12 times 11 in the numerator. That's like a 6 times 11, because 12 over 2 is 6. 6 times 11 is 66. So this tells me what the denominator is going to be for all of these. And that would be 31 over 66. And that happens to be reduced. 31 doesn't go into 66. 31 is a prime number. So that's the answer. All right, let's find the probability that one is a man and the other is a woman. Well, how many ways can you have, this is like doing two different tasks. It's and, it's not or. We're not going to add anything together. One of them has to be a man, one of them has to be a woman. How many ways can we make that happen? Well, the first task is, how many ways can you choose a man? There's 7 men, so there's 7 ways. Then you have to choose one woman, 5. There are five women. You could choose them in 5 different ways. So there are 35 different ways you could choose one man and one woman. And technically speaking, you could say it's the combination of 7 choose 1 times a combination of 5, 1. That's going to be 7 times 5. And the denominator is the same, 66. So 35 over 66. That is slightly over half, right? 33 over 66 would be 1/2. This is a little bit more than that, 35 over 66. So most of the time, more than half of the time, when you choose 2 people out of this group, you're going to get one of each, one man, one woman. Third one, find the probability of at least one man, which is equal to, we're looking for, let me write it down, at least one man. Well, how many are we choosing? We're choosing 2, right? So that's equal to the probability of exactly one man, or plus the probability of exactly 2 men. I'll put both men. But remember what we frequently do when we see at least one. The complement of that event would be there is not at least one. It means there is none, 0 men. So this is equal to 1 minus the probability of 0 men, which is equal to 1 minus, if you have 0 men, you have 2 women. The probability of getting 2 women is really easy to compute. This is 1 minus, we know the denominator is 66 because that's a number of ways you can choose 2 people out of this group. How many ways could we choose women? Well, there are only 5 women. We need to choose 2 of them. That is the answer. Not simplified, but very simple. Because remember we did above, or at least I told you above, I've done this one so many times, the combination of 5 things taken 2 at a time is 10. So this is 1 minus 10 over 66, which gives us 56 over 66. Because 1 is 66 over 66. 66 minus 10 is 56. So if 10 times out of 66, you're going to choose both women. The other 56 out of 66, you're not going to have both women. You're going to have either one man and one woman, or 2 men. In other words, at least 1 man. So this is the answer for the probability of at least 1 man. And again, whenever you see the probability of at least 1 something, maybe I'll write this down as a reminder, and this will be probably terribly confusing because I'm going to be very informal here. the probability of at least one something is equal to 1 minus the probability of 0 somethings. I'll write it out, 0 somethings. So in our case, at least one man, the probability of at least one man is 1 minus the probability of 0 men. All right, this again is very informal. You can ignore that if you like.